So let's take a look at an example here. I want to find dz dt giving z equals cosine of x plus 4y, where x is 5t to the fourth and y is 1 over t. Now, as a reminder, dz dt will equal dz dx times dx dt plus dz dy times dy dt, and actually we should rewrite these as not these straight derivatives, but we should actually write these as the partials. The partial of z with respect to x, the partial of x with respect to t, plus the partial of z with respect to y times the partial of y with respect to t. So if I break this down component by component, the partial of z with respect to x, that's going to be the derivative of this with respect to x, which will give me a negative sine of x plus 4y. The partial of x with respect to t, that's a derivative of this with respect to t, and that's going to be 20t cubed. And then I need the partial of z with respect to y. So let me come down here a little bit more. The partial of z with respect to y, and remember z was given as cosine of x plus 4y. So this would be a negative sine of x plus 4y times the derivative of the inside based on the chain rule. So I'm going to move my negative out here and put the 4 right there. And then the last component, which I'm going to slip over here, is I need dy dt, or the partial of y with respect to t, where y was 1 over t. That gives me a negative 1 over t squared. So now if I put all these together, I end up with dz dt will be equal to, see, negative sine of x plus 4y, that's a y, that's this piece, times this guy, which is 20t cubed, plus this guy, negative 4 sine x plus 4y times this, which is negative 1 over t squared. Well, I can cancel out these negatives and just leave me there with that positive. And then I should certainly do a little bit of simplification here, because I have, see, 4 sine of x plus 4y, and I have a negative sine of x plus 4y. So if I factor out a negative 4 from here, that will give me 4 sine of x plus 4y times, this would be negative 5t cubed, plus 4 sine x plus 4y times 1 over t squared. Now these are common, so I can factor out both of those. Oops, there we go. And that will give me, see, 4 sine of x plus 4y times 1 over t squared minus 5t cubed. So that would be my answer. Now notice if I just did a straight substitution, what I end up with is z is equal to cosine of 5t to the fourth plus 4 over t. And if I just simply go directly here and find the derivative of z with respect to t, I will get a negative sine of 5t to the fourth plus 4 over t times the derivative of the inside, which will give me 20t to the fourth minus 4 over t squared. And then, obviously, if I factor out the 4 or the negative 4 here, I'm going to get the same answer. But notice over here, I still have this with x's and y's. And if I substitute in the value of x, which is 5t to the fourth, right there is my 5t to the fourth. And y was 1 over t. Well, right here is my 1 over t. So these are identical. And to get this as strictly a function of t, that's exactly what I should do. I should substitute in the value of x as a function of t. So both techniques resulted in the same thing. Obviously, straight substitution, then taking the derivative in this instance was much more straightforward, much easier to do. But that's not necessarily always the case. So you definitely want to be capable of doing both.